So a little bit of context in the world, more and more dunes are artificially constructed, and there is different methods. We can put a different density of vegetation on the dune. You can also make dune with hard core, rock core, or geotextile core. And the question is that the impact of this dune construction on the geomorphological evolution of the dune beach system is still not well understood. So the objectives of this research are firstly methodological objective, testing the use of the CFD tool in this type of environment. And the second one, more scientific objective, is to know the impact of this artificial coastal dune shape on the wind processes. Our study seat is located at Leucate in the south of France, in the Gulf of Lions, so on the Mediterranean coast. As you can see on this wind rose, the wind is very dominant offshore and very strong. We have a lot of offshore storms during a year. And here you can see the picture of our dune, so very little dune with a maximum height of 2.5 meters. And you can see also that the crest of the dune and the landward part of the dune is highly vegetated. This dune has been artificially constructed since 2004 and with different methods of construction, and these different methods create variable dune shape. So as you can see here, on the northern part of the dune, there is a very symmetrical shape with a steep lee and slow slope. And on the southern part, as you can see here in red, there is an asymmetrical shape with a lower lee and slow slope. And there is a double crest on the dune because of the two straight line of rock that be in the core of the dune. And in the northern part of the dune, there is no rock core, just a mount of sand. We used some CFD to make this work. As you can see here, it's our computational domain. And the particularity is that we apply a variable surface roughness on the computational domain. As you can see before, there is a lot of vegetation on the dune and on the landward part of the dune. So we put a different Z0 between this part of the domain and this part of the domain, which is composed by sand. For the transport formula, we use the Leto formula. For this presentation, I will show one simulation of wind speed, but in the article we made a different wind speed simulation. And I will talk about two oblique wind direction and one near perpendicular wind direction in the simulation. We made validation of the CFD with 9 anemometers on the field. So we compare both modelization and observation. And we observed a very good correlation between wind speed calculated and observed with less than 1 meter per second difference, or a little bit more in some places, but always less than 2 meters per second. For the wind direction, also the wind direction distribution over the dune profile is respected between the observation and modelization. Even in the most complex zone, as you can see here, in the zone of recirculation, we have a very good correlation of the wind direction. I'm going now to talk about the results. Firstly, the result of the perpendicular wind. So here you have the map of the CFD, and here the northern profile of the dune, and here the southern profile. So for a perpendicular wind, we observed a speedup factor by 2 on the northern profile and 2.3 on the southern one. And on the southern one, you can see two peaks of wind speed because of the double crest of the dune shape. We also see a flow deceleration on the lee side of the dune and flow deceleration also on the southern part, but the deceleration is less marked on the southern part than on the northern one. We can see concerning the direction that we have flow separation on the northern part, and on the southern part we don't have this flow separation, just a little deviation of the wind. Concerning the oblique wind now, we can see that there is a weaker speed up on the dune the more the wind are oblique, in both cases, on the northern and southern profile. We also see the more the wind are oblique on the beach, the more the wind speed is higher on the beach for both profile. And concerning the direction, we see on the northern part, we don't see the recirculation as for the perpendicular wind. We just see a very strong deviation on the lee side. And on the southern part, we see also just a deviated flow on the lee side. Concerning the sound transport result, we can see here modelization of the shear velocity. And we can say that on the northern part of the dune here, there is a lower shear velocity than on the southern part. You can see here in dashed red line the threshold shear velocity. So in the lee side of the dune, of the north dune, we can see that most of the wind don't are above this threshold, whereas on the southern part, the shear velocity are always above the threshold. What it's mean in terms of sound transport? In the northern profile, we see that there is no or very little sound transport on the lee side of the dune and on the dune toe. Whereas on the southern profile, we see that there is a very significant sound transport on the lee side of the dune that is very different than the northern part of the dune. And after we see that the more we go away from the dune, the more we have sound transport in both cases. Of course, because we have more wind speed on the beach. In conclusion, I can say that we modelized a separated flow on a relatively small dune. So in modelization and observation, we make this conclusion. It's not common because in most cases in the literature, we see this separated flow in very big dune systems. The local dune system is only 2.5 meters high. And we can say also that the created dune affects significantly the aeolian process and the sound transport over the whole beach dune profile under this offshore wind. We can say also that the CFD tools accurately reproduce the aeolian processes, even the most complex ones, so in the recirculation zone. And to finish, I can say that the dune construction methods dictate its morphology at the beginning of the dune life, and it continued to influence the wind process and the sound transport even after 2 decades of construction of this dune. Thanks for your attention.
Brilliant. Thank you so much, Antoine.